And the goal of what I'll be presenting to you now is actual use cases where we are helping impact business outcomes, right? And I'll talk to this on the wireless side, I'll talk to this on the wired side, and then Abhi and Jake will walk you through what we're doing on the WAN side. But today, just to, again, summarize what Bob was saying, we are ingesting telemetry from the wireless, from the wired, from the WAN network. We even have a client SDK so we can get information from the clients from Android and Windows. And this is where the SLEs or the service level experiences come into play, which then become the AI primitive baseline for Marvis to act on and to give you proactive actions and proactive recommendations. So to your point of what is Marvis? Yes, Marvis is a reactive tool for your help desk. Marvis also, more importantly, is a proactive tool to notify you as a network administrator what's happening in your network across the full stack. So today is all about AI ops for the full stack in the enterprise space. So let's take the example of RM. We talked about reinforcement learning in the slide Bob was showing you. How are we really using that? So as Bob said, when he began Airspace and he talked about on the RF world, channel and power, the dance that we all play to make sure that the network is operating correctly for Wi-Fi clients. And you talked about the warehouse, right? The only data in a controller world is, oh, how one AP sees the other AP, because it's a controller. It doesn't have the wherewithal to take into account all the client telemetry information. Now with the microservices cloud architecture, with the ability to ingest, we get statistics for every client from every access point every 2 seconds. And that is giving us a view from a client perspective of coverage, of capacity, right? No longer is the world a coverage-based world only. We all know, we're all running Zoom sessions, Team sessions, heavy bandwidth, heavy latency sensitive applications. The question is, how do we adjust the RF network dynamically, but gradually so that you always have the best user experience? And it can't be a wholesale change. I can't change my power or my channel across all my APs in a warehouse, but I can do it in a select area when I am seeing clients in distress, right? And that is where reinforcement learning comes into play, because what we do is, first of all, we take into account our capacity, our coverage, our roaming SLEs to provide feedback into our RRM engine. So the reason we say it's AI-driven RRM is because of the AI primitives here coming into play. And then we also measure that with how is the every user experience on that network. So when RRM makes a change, and if we see that the coverage, the capacity, the roaming has not improved for that client or the set of clients we're trying to optimize for, we will tell RRM that was a bad decision. So we'll never make that change again based on those conditions. However, if we see the capacity, coverage, and roaming SLEs per client improve, then it's positive reinforcement. Okay, RRM, you did a good job. That is the direction to go to. So we're constantly training that model automatically based on looking at a change was made, how was the end user experience from a coverage, capacity, and roaming perspective, positive, good job, negative, bad job. And that's the reinforcement learning model. So this is, now, why are we so proud about it? You all run controller-based networks. You all know the reality of when you turned off RM from certain vendors, when you didn't. In the Juniper Mist universe, all of our customers are running this. And when I say all of our customers, I'm talking about the world's largest retailers, the world's largest e-tailers, be it stores, be it warehouses, enterprise corporate spaces, healthcare. The world's largest healthcare organization is one of our customers. They're running this with all the medical equipment. Schools, dorms, this is running everywhere. It's sort of a given because it does positively impact the end user experience. So this is a case of machine learning, deep learning with reinforcement happening in action day in, day out. Let's go to another one. This is my personal favorite, self-optimization with auto cancellation, dynamic dual 5. Now, these are all features we are familiar with, right? Hey, I have too much 2.4 coverage, but I want to use dual 5. I have a mixed mode network where I'm running 2.4 and 5. What do? I would love to go to a 5 GHz only network. Can I do that, right? So here's a real world example of a customer where it was a dual band network. They had clients on 2.4. They had clients on 5. They did everything right from a configuration perspective, or so they thought. But what was clearly being measured for that particular corporate location was that the capacity SLE, which is an aggregate of all the devices connected to the network and the capacity they're seeing, was taking a dip. So even though the wireless administrator did what they have always done, in the controller-based legacy world, they were not doing right by the end user, and our SLEs caught it. Now, again, they didn't have to make a change. What happened essentially was RM saw the changes, RM looked at the devices in distress on a per band basis. RM basically kicked in and enabled the dual 5 configuration. And once it did that change automatically, as you can see, the capacity SLE went to above 99%. This again is self-driving in action. So there are things that the AI engine does in the backend that you don't need to worry about. There are things, what we call driver assist mode, where the AI engine will notify you to take action because it's outside of the purview of the AI engine. And we'll talk about that as well. Here's another one. And this is a very common one. And you might say, well, other vendors do it all the time. But again, it comes down to efficacy of data and the impact of the end user. So based on the telemetry information we're getting, based on the capacity, the coverage, the roaming SLE, we are now able to very quickly pinpoint areas that may need AP augmentation or repositioning because of actual coverage hole problems. Now, coverage hole not defined just by, hey, I'm not getting an X65 dBm in this area, so I need to add another AP. Coverage as defined again by, I have users not getting the throughput that they should be getting. I have users who are not able to run applications when they come to this area. And we are not looking at just the fringe AP. So here's an example, again, of a real world location where you see a lot of APs in red. Those APs in red are what we call transitional APs, which means a client was connecting, take guest Wi-Fi and retail. Client came in, connected, client walked out. The device stays connected to that, that entry exit AP for a while. That does not mean there's a coverage hole issue here. But there are certain areas within that location where there is actual coverage problems because when I had a dense or peak traffic in that area, I was not able to serve all the clients effectively. And that is what it calls out as a true coverage hole issue versus giving you false positives on where the issues could be just based on RSI of clients. Right? So this is, again, the intelligence that is built into the model. We're looking at per client SLEs for coverage, for capacity, for roaming from a post-connection perspective. We're able to highlight exactly where we need to either move APs or augment that area to provide more capacity, assuming your WAN link is okay, you have bandwidth there, to make sure that you're able to optimize the user experience.
Question.
Absolutely.
We're talking about optimizing for user experience, but different users require different things depending on their environment. So I'm going to go back to warehouse because I have a strong love-hate relationship with warehouses. And then you brought up a couple other verticals, and I'm going to pick on just any office or even schooling. The end user experience needs to be very different there. And you're tracking different metrics. So I'm in a warehouse, I'm zooming around, I need fast handoffs. But if I'm in a university, I'm a student in a dorm and I'm downloading large legally obtained files. So how are you telling the system, well, this is what I care about for this set, and this is what I care about for the other set?
Great question.
It sounds like it's one big hodgepodge. How do I get real specific on what's important to my clients in each different situation?
Absolutely. That's a great question. Abhi, chime in here as well, right? So when I deploy a Juniper Mist network in a warehouse, vis-a-vis a hospital, vis-a-vis a university dorm, and when I start giving you the SLE view of what is success, it's based on the peer correlation and a side baseline for that environment. So it's not like I have a metric of, hey, roaming should always be this, and capacity should always be this, and coverage should always be this. That is tailored to the environment. So for example, my roaming requirements in a warehouse with robots is much, much, much more stringent compared to a dorm, right? But not so much compared to healthcare, because they may have similar roaming issues as well when they're, when they're all running to help a patient. Go ahead.
So then you are saying, okay, this environment, this is a warehouse, and this is what
the system's learning by itself. That's the beauty of it. Here, I am not looking at giving it, or here's a warehouse model versus here's a hospital model versus here's an education model, right? Based on the device connections coming in, based on what the network is seeing of the client connectivity, the roaming, et cetera. And you do have the concept to also, the one setting we do give the flexibility to the admin to do is, hey, what is my roaming SLE level? Is it my default, or is it, sub 60 milliseconds because it's active roaming, or even lesser in some cases, which is the most interesting. So you do have the ability to say, trigger a positive or a negative or a not so good experience based on my roaming SLE. The same thing for successful connect. I should be able to connect within less than a second or 2 seconds or 4 seconds. So you do have the flexibility. Once you measure, you say this is what is success, then the system starts sort of calculating the percentage success, percentage failure in user minutes based on that threshold.
So then, okay, I can adjust my roaming.
Your service exactly. What do you expect a device to be able to connect in or roam in?
So, but then when I'm in a high capacity environment and throughput's my largest concern, the system has learned through user activity that
yes,
that's what
the baseline
cares about.
Okay.
Yeah. Okay.
Another question on that. So you have all the analytics to understand, performance. Can you make recommendations on AP placement based on,
That's exactly what the previous one was. So when we talk about coverage hole, we will say this is what your current AP layout is, and then we would recommend that you add another AP in this area. So
I understand now. Thank
and
you.
it's again, that's a Marvis action. You don't have to sift through data. You don't have to look at SNR. You don't have to look at retries to say, oh, where am I having a coverage hole? The system will do all that work for you.
So what are these dots represent on here as far as placement goes? I mean, is it like green? That's ideally where you should put things. Like how?
No, this is just So this is the APs where they don't have a problem at all. Coverage, capacity, roaming is fine. Orange is potentially they have a problem.
I see.
But even there, where if we looked at just RSSI, then you see a lot of red. But where the Marvis intelligence comes into play based on spatial analysis with graph analytics is it's only that circle that is having a problem. So if I take it back to the previous slide, you don't have to go into the minutia of everything that's red. What you will see is as a Marvis action recommendation, hey, you need another AP in this area because that's the problem.
Got it. Thank you.
So are you able to do anything as far as outside of just, add an AP, move an AP, try a different antenna, things like that, reposition something? Can you get that level, or is it just, hey, there's a gap here, add an AP, or maybe move this one 5 feet that direction?
The latter, yeah. Now, I do want to go from the Wi-Fi world to a little bit on the wired side. So we'll begin with what we call proactive RMAs. And that also is like, we see it as self-driving, right? Today, or what your typical experience, you have issues on an AP, you call the tag team, they'll say, what rubbish, AP is fine, get this log, get that log, I don't believe you. And then it's a sort of when they finally agree, it's a hard down situation, they'll say, okay, let me issue you an RMA. Our goal is, again, using self-driving is to be able to look at how the APs are doing, try and recover the APs automatically, whether it's a radio issue or a cable issue. And if we can't do so, we will proactively issue an RMA to you saying, hey, this AP is unhealthy, and therefore we would like to RMA the AP. So we'll still need your help to get a tech on site to pull the AP down and ship it to us. But you don't have to worry about proving that, hey, this AP is going in the wrong direction. And this is where a little bit of the prediction model comes in, because we can already predict based on the telemetry coming in the direction of the AP. Our goal is not when the AP is down that we tell you, hey, by the way, RMA the AP. The goal is even before it gets that state, we're not able to recover it, to notify you, we need to RMA this AP. And this happens on two conditions, right? So there could be Ethernet errors. In that case, we'll try and auto recover. If we cannot recover, we will then issue the proactive RMA for you, right? So we can do this for radio issues. We can do this for layer one connectivity issues from a bad cable perspective. Bob, if you want to talk to this slide on again, our journey here and the various models we went through for all those use cases before. So this is all about how when we began our journey at MIST, we were following a moving average model, and that led to a data efficacy of only 50%.
This is an example where we all know, hey, when it comes to computer vision, I mean, computer vision has changed how things are getting done, right? All that driving car stuff is happening because computer vision now works. And that's because of these deep learning models we have now for doing that. In our industry, this model here is a deep learning model. I mean, to your point about these thresholds, how do we set a threshold for, hey, I'm a higher ed or I'm a distribution center, right? This is an anomaly detection thing where the baseline is automatically determined over the last 3 months, right? So I think that's answering your question. Is sometimes the thresholds are determined manually, like, hey, I'm in a warehouse, I want fast roaming or voice, right? I want the RSSI at minus 60. You know, where do you want your RSSI? What's your definition of success? This is an example though, where none of this stuff worked, right? You know, trying to do anomaly detection, we've been doing it for years. It didn't work until we got to this. You know, in this, we have customers now where we actually get anomalies, you know, that's back to the, 300,000 access points in a place, and we're trying to find the missing VLANs out of 5 missing VLANs, right? Type of problem. So this is an example of deep learning actually making a difference in our industry. Does that make sense?
And
This is called long-term, short-term memory algorithm. And this is where that baseline, right? We trained the model over the last 3 months worth of data to try to do that prediction of, are we going to have an anomaly? And the big difference here is these models here only predicted the average. This model down here also predicts the confidence level, right? You know, instead of trying to predict what the next number is, I'm going to predict also what the confidence interval is.
So is it possible for a customer to give you an event window so that as the system is measuring and quote, calculating a baseline, that event window has meaning? For example, baseball games happen, but they don't happen on a regular set basis. So what's normal for, say, fan-facing Wi-Fi is only relevant while there's a game happening versus not. So is there a way to do that with this type of system?
That's called seasonality. You know, so like during the baseball season, you know, this would learn what days your games are on, right? You know, so this is a model that would learn seasonality. Like, you know, if I play, you know, whatever, every other day or whatever, you would know that this is a game day. This is normal for game day.
But we would want to go one step further to be prescriptive, like, because it isn't predictive to say, well, we play games every Tuesday at this time. It's, well, sometimes due to rain, it's been shifted to the next day. So we want to basically say a game is happening, you know, right now, or will happen in 2 hours.
Yeah.
Now define this as an event window so that we're being prescriptive.
Yeah, you can be prescriptive. And this is where it hurts people's head on how this stuff works. You could be prescriptive and say, hey, here's my schedule. I'll tell you when the game is on or not.
Yeah.
These models actually know if the game is on. They build models. They will build a model that actually learn how to recognize whether the game has actually started.
that's where the neural network aspect comes
Right.
into play, right?
This is the trick. This is the amazing stuff with this stuff here. You would just build a model that would tell you whether or not the game was on. Now you could be prescriptive and make your life, you know, try to make it less tricky and say, hey guys, I'll tell you, I'll give you some information. They call that prior information. I'll give the model some prior information to help it out to make better predictions.
So does that mean it's looking, okay, it's game day, 40,000 people have shown up. Like those are the sorts of metrics that it's going to use to say, okay, I need to scale up for this.
The model, the models will work better if you give it prior information. Like, hey, if I tell the model that, hey, you know, this is game day, we sold 40,000 tickets.
Yeah, but that being said, right, Bob, end of the day, you may have 40,000 people, but you're already designing that network to be able to accommodate a certain number of clients per AP. So from an AP perspective, it was like 0 the last 7 days or 10 days or 30 days, and then suddenly I saw a spike. So the model will accommodate accordingly. It won't show you failure for the day of the game. What it will show you though, because it's seen this pattern that yes, there is seasonality here, may not be every Wednesday of every week, but I do see a spike. When I see the spike, what is my scope of impact? Am I seeing high failure rates with higher client connections or high failure rates with the same number of client connections? And it'll build that correlation there.
No,
And it's inline data.
It is,
right?
it is
So-
looking for anomalies during the
During the game,
the baseline.
yeah.
I mean, so there's a baseline assumption that, you know, this is what a normal game looks like, and this is what normal non-game look like, and then it'll look for anomalies during, hey, game is on, you know, is there any anomalies relative to the last 30 games I've had? You know, has something gone wrong that I haven't seen before?
Well, this is exactly, so this is too why I wanted to be prescriptive to say, this is an event window, this is a game happening, now baseline it so that in the future you can go back to it. And I guess my question is, is that a technology that exists in the product, like in Mist today, or, yes, there are algorithms out there, but I'm not a data scientist, so I'm not going to build that tech. That's why I would want to exchange money for product.
The answer, this exists in the product today. That LSTM model exists in the product today, and it would learn your game day.
And I can say, like, I've got a game on this date. This is what good is.
You should not need to. So even if the game happened in the last 3 months, it'll already have that trend. So
the answer, the current thing doesn't take that prior knowledge yet.
Okay.
The current product doesn't do that. It doesn't need to do it. It would learn,
Exactly.
It would learn to recognize what a game day looked like. Hey, I see a game going. It would know that. It would say compared to the last 30 games.
Yeah.
Is there any?
Forget even the game day. I take a even more simple example: corporate enterprise. People are going to start coming in Monday to Friday, Saturday, Sunday, very low traffic. Does that mean that I have high failure rates on Saturday, Sunday? No, I don't. But that seasonality, the model is already learned. So it's not going to call out, hey, my roaming dipped to like 0% because there were no clients there. There was no failure to look at. Right? So
not just events like baseball games, well, let's say operational events, Patch Tuesday, or even worse, as we deal with externalities such as cloud, et cetera, and our service providers have patch days that for the MTU is a great example of, like, is there a model that can predict or recognize, obviously something obvious as in Patch Tuesday, but something not as obvious as in Patch Tuesday for my cloud provider that may or may not impact my APs or my clients connecting to AP to a service that's hosted in the cloud?
it's not going to predict that, but it will tell you if there's an end user impact happening right now, I'm having a problem and why that is, right? So it could be a patch day from an ISP perspective. That doesn't mean you're not getting impacted. And if you have the SD-WAN solution, if it's doing its job right, it's already put you on another link, so you're not impacted by the patch Tuesday that the ISP is doing. So that would be the goal here. So for us, the goal always is every user, every minute, every session, give you an impact of the user experience. So yes, there's a baselining aspect, there's a localization aspect of the environment, but the key part is when there's a problem happening, tell you why, right? So,
but the main point is, even this algorithm would do seasonality to try to predict seasonality type of events. The main point is this deep learning thing was the accuracy.
the efficacy aspect of it.
The efficacy. This is where we got to the point where this has to be, you cannot basically be waking up IT guys at 2 a.m. unless you're very sure you've got something that's worth their attention. And this is the big thing that happened here. This got us to a point where we're like 99% sure. When we say there's an anomaly, you better take a look at it.
So talking about mutual information, right? We absolutely understand what are the nature of devices that come into a network. This is an example of, a particular switch getting data for the fact that what are the nature of devices that are connecting. And again, what is the seasonality of these devices? What is the nature of them? A camera, for example, is constantly streaming traffic to the DVR. Now, at any given point in time, if we figure out there is one camera in your entire site that isn't operating, where either the TX and RX became 0, or TX or RX became 0, or there is a link that is down, but the power is still being supplied, any of those reasons, any take your corporate and enterprise, take your retailers. This is a very common use case, and the solution there is to go reboot the port or power cycle the port. Can we do that already? Hardware anomalies like this are for us an easy use case for us to go after, and this is where we talk about, we know this camera is bad. You give us permission the very first time in such a use case. We go and take care of it. We go and bounce the port for you because we actually manage the switch network too now. So we have the ability to automatically reboot the port, make sure the camera comes online. If not, further report saying, whatever remedial action we took did not solve the problem, but there's an anomaly here.
Am I telling Mist that that's a camera, or are you guys figuring out that that's a camera?
We figured it out.
You figure out that it's a camera. Okay.
And is Mist part of Junos? Has it been coded right into Junos, or is it an agent running on the wired gear, or is it simply reading port stats? Like, how is it collecting that information from a wired network?
Junos, from the day it was built for automation. It ran a netconf and restconf from the day it was built. We use all a secure connectivity from the Junos back to the Mist cloud, gather exactly what you're speaking about, telemetry details from every single switch as required.
Okay.
Does it also ingest syslog information, or is it simply the metrics?
No, yeah, I'll talk about another use case, metrics events. So there are two buses that leave the station from a switch perspective. One is asynchronous events that matter to us, or interesting events that matter to us that come to the cloud, as well as stats like port stats and LLVP statistics, etc., that come to the cloud. Both are received to the cloud. So we take interesting events, send back to the cloud. We also send the stats back to the cloud.
But when you say interesting events, is it because you've predetermined that it's interesting, or it's because the ML algorithms have detected something's weird, so it's interesting?
From a perspective from the switches, it's always about what actually affects the end client. So we have all things that are affecting the end client. For example, we enable ARP inspection, but the DHCP snooping table doesn't have a client in there, and that event is already in the cloud telling you that this will impact the client. So it's not about every single log that's there as a line item in, if you do show log, that doesn't come to the cloud. It's about what affects the end user.
Well, so for example, let's say you're drawing power to those cameras.
Yes.
And let's say that, for some reason, these cameras are rebooting, right? And you're trying to figure out, well, why is these cameras rebooting? And if you go on the box and you look at the logs, you'll see probably some power related syslogs. Does Mist, detect that these syslog events happen that are kind of out of the ordinary to bring it to your attention that, hey, this camera, this bad cable is really a result of, power mismanagement and or maybe a miscommunication between the end client basically saying, hey, I need 3 watts, but it really only needed 10 watts, and there was just something weird happening there.
So again, all of this as part of the endpoint correlation, right? We have an SLE on the wired side that is dedicated to power. And similarly, we have dedicated, for example, if the camera is rebooting consistently, we probably are looking at one of 2 reasons, right? You're having a duplex mismatch, and the camera doesn't want to play well with the auto negotiation, or there's a bad cable. All of these details are captured from an endpoint perspective and tell you exactly, okay, on this particular switch, you have a power budget of 120 watts. You're adding a camera right now. You're asking for 3 more. There's no more power. We tell you that.
Right. But did you tell us that because you've coded that into the analytics decision tree, or is there a machine learning algorithm that says, I normally see these kinds of syslog messages that are happening from this box, and then all of a sudden I'm seeing something that I've never seen before, and that's an anomaly, and start building some kind of...
It's not machine learning on the box in the syslog, it's machine learning the port usage. The port usage from a power perspective, the port usage from a TXRX perspective, the port usage from a number of events generated perspective. So for the cloud, it's all about what are the port stats, which could be any of the above failure issues that you talked about. And then the ML engine above says, okay, this is the typical port behavior I've seen. I've seen an anomaly here. Let me now trigger an action. That is how it works to capture some of the issues you saw. Right? So the whole goal is that you shouldn't have to, as a network administrator, you should not have to say, hey, go look for this problem, this problem, this problem, for this problem. Here are my sort of bounded values. Then we have failed. Because then it's still manual for you. The goal for us is to automatically know for the common issues that we see. And this goes back to what Bob was talking about, is working with the TAC teams, the customer success team, and what are the issues that they typically see our customers dealing with, and building those models preemptively into the product. So I'll be really quickly before we move on. Jake, if you're ready to.
Talking about upstream issues, right? So once the devices get on board, we still have other use cases where, a client is unable. It's onboarded, successfully connected. Now there's no response from the default gateway for its hour. Or DNS, which never is a problem, could be talking about, we do not have DNS issues. Again, all of these are built into the SLE framework, and as anything built into the SLE framework directly comes into the conversational assistant as well as smartest actions. So if we know there's a consistent failure on any of these peripherals, not usually have from the same, not maintained by the same IT team, these are DHCP servers, DNS issues. We talk about how we can at least tell you that this is where the issue is. Please look at this direction. And that's the meantime innocence comes into it. This one is an important one. We talk about this is a real use case of how a model is used to talk about missing VLANs. The use case is you have your APs connecting to a switchboard. Your APs need 4 user VLANs that need to operate. On the switchboard, you either have no VLANs configured or you have only a couple of them, and the other couple are missing. The way it pans out is when a customer is roaming from one AP to the other, they are going in there and they say, whenever I go into this spot, I have no connectivity. It's again, the end user experience is either Wi-Fi sucks or I'm unable to connect, and it's always in this spot, it fails. Now, across 150,000 APs in a network, we were able to detect 27 missing VLANs. What this irons out is all the VLANs. For example, you may have dedicated black hole VLANs that you need that may be configured on your APs, and we won't know it's a black hole VLAN or not, but we understand from the traffic patterns to get to know where exactly the issue is. So a lot of basically weeding out in order to find out which are exactly true missing VLANs is the goal for this particular model. And that an example of it doesn't matter if it's a third-party switch or a Juniper switch. Juniper switch, you have the option because it's Juniper switch. We can go remediate that in terms of fixing what's missing. This is the same aspect. The bad cables, I think this is one of the things, that where we talk about going bad kind of scenario, right? You have, 2 power pairs, 2 data pairs. If one of them is going bad, these are areas that we can actually identify, again, based on heuristics that we see and say, okay, this particular example, we have a bad cable for you to look at. And usually layer 1 issues are the last ones to get looked at. And we bring that to the forefront. And when we went into a manufacturing plant, where they said, we have 40 Juniper switches that we've been running for a long time. And that's, you say, wired assurance is the best thing ever. Let's just put it on. We just ran it in monitoring mode. The next day, we spoke about 3 cables which we identified as bad. One of them was the user who reported that they had connectivity issues intermittently. And that eventually turned out to be a bad cable, which we identified. That was the last place that they did not look at. They looked at the configs, they looked at everything else. This may get overlooked.
They looked at all the logs, found nothing.
And this is a really cool use case for us to identify bad cables. A very near and dear topic. We know spanning tree is there for a reason, for us to not have loops, but we do have loops even after that. We say, and there are indicators for that as well, right? You see abnormal amount of TX or RX, especially from a multicast and broadcast perspective. Those are areas we can look at. We get abnormal amount of TCNs, topology chain notifications from the system. There is enough evidence for us to actually tell when there is a loop, but also as Bob was talking about, right? Mutual information and event correlation. We know there are probably 2 big reasons why a loop would occur. Somebody changed the config, or somebody added if a system was working great, it wouldn't form a loop automatically. Something had to change. What was that something? And that's where we have events for all of these. Somebody added a new port wherein a switch was plugged in, or somebody made a config change. And this is the kind of nature. Currently, the system already detects there's a loop. The detection of event correlation is something that we're working on to say there was a loop identified at 11:30 in the morning. At this point, we also see these 2 events happen at the same time. I think we should go shut this board. Your loop will get resolved, and that's the end goal.
Is it possible, and I'm going to go back to Jeremy's example, for Marvis to learn from Mist? So we're talking about, okay, so here's how Marvis can understand that it's game day based on wireless predicting, like it knows the seasonality. Can it also pick up on hardwired triggers that would indicate that as well? So before everybody shows up and the big board turns on, so we start seeing data being streamed up there. Is there any bridge between those where Marvis can learn on the wired side to help with the wireless?
Absolutely. I mean, we have once I finish this, we have a whole slew of what we call as day two part of it. We collect data from wireless, wired, and WAN. And Bob was talking about the action framework, and then also the conversational assistant framework. I'll showcase both the wired side as well as the WAN side from the action perspective, as well as from the conversational assistant perspective. But as long as it's a Juniper switch, yes. The answer, a short answer is yes.